It's implicit differentiation. Let me see. Oh, actually, I did want to say some things, we'll get to here soon, some things about the notation from the last section. So I got a side note. Oh, 3.4 was the chain rule. And then we're going to get into 3.5. Okay. We had a composition of functions. We called it h of x. And it's some function f composed with g of x. We took the derivative to get h prime of x would equal f prime of x with g of x as the input. And then multiply by the derivative of g of x. So say g of x equals u, or I'm going to put u, let u equal g of x. And y equal to f of u. Okay. We'll take the derivative of y with respect to x, dy dx. And this would be, let's see, I wrote the derivative of y with respect to u, dy du, multiply with the derivative of u with respect to x. So that's the derivative of the outer function. And then the derivative of the inside function. That's it. This is also kind of good as an intro to the next section. What we will do is go into 3.5. As our goal for the day. We'll see. Okay. Implicit differentiation. So if you can't, usually I guess if it's useful if you can't write y explicitly as a function of x, we will differentiate both sides of the equation. And remember that y is some function of x. So we'll use the chain rule and then kind of work out the problem to isolate y prime. Okay, so first, y is a function of x. differentiate y and apply the chain rule. Well, let's see, differentiate. That's fine. Anything else? I think we're okay. We're just going to do some examples. Number 1. Take the derivative of some function f of x cubed of 3 times f of x squared times the derivative of the inside, f prime of x. It's not really new notation, but the notation we're going to stick with is to write this as that function y, and this would be y prime. Let's see, equal to 3y squared. Okay. And again, don't forget, that's the chain rule right there. Number 2. The derivative of sine of f of x. Okay, the derivative of sine would be cosine, and then you leave the function sitting inside. And then multiply by the derivative of the inside function. And that comes from the chain rule. Okay, we're going to have some notation. To write it more like this. D dx of sine of y equal to the cosine of y times y prime. Let's do one more of these where we take the derivative of e with the function in its power, f of x. So the derivative of the outer function, which would be e to the x. So you'd get e to the x but you're doing a chain rule here. So you leave the inside function. Like this. Then multiply by the derivative of the inside function. What we'll write instead is the derivative of e to the y equal, because y is some function of x, we get e to the y times y prime. From that rule. So I have some steps to work through. Let's see. Solving equations with implicit differentiation. Cool. Okay, first, differentiate both sides of the equation. See, I just put, when you take, or remember to use the chain rule. Or remember that y is a function of x when you use the chain rule. Or I guess you could put, which means use the chain rule. And the last part is to isolate y prime. Solve for the derivative of y with respect to x. All right, some examples. First. Okay, before we jump into this, I want to see if there's any other hints or like suggestions from this section of the book. One second. And we're back. Okay, cool. So I guess it is to solve the resulting equation for y prime. Write that down. So that's how we want to introduce. Just say find dy dx if blah, blah, blah. If x squared plus y squared is equal to 4. Let's write dy dx on both sides. The derivative with respect to x. This kind of misspoke just a second ago. And this. That's the number 4. So when it's just a variable x, no worries, take the derivative 2x plus. Right here, y is a function of x, and we're doing a derivative, so it's going to be a chain rule. 2y to a power 1, then multiply by the derivative of the inside function, y. And we're done with that part. Equal to the derivative of 4, so we're equal to 0. Now you want to isolate that y prime, and we'll be done. All right, subtract that, divide both sides by 2y. Got negative x over y. Going to draw a quick sketch. This would be a circle with radius 2. And I found a point on the line. So if you put in x equals 1, you'll get out y equal to square root of 3. And I wrote that the slope of the tangent line at that point. So we're going to say the slope, m for slope, of the tangent line at the point 1 root 3. From the work we just did, it would be a negative x over y. So negative 1 over root 3. So at that point right here, you've got a negative slope, that negative slope. Last little bit here is the slope of the tangent line at 1 negative root 3. Would be, from the work we had before, y prime is negative x over y. So negative 1 over negative root 3. It's positive 1 over root 3. So you have a positive slope for that tangent line. That's good enough. Let's move on. So the next example, we want to find dy dx which we call y prime, if 5x squared plus 3xy minus y cubed equals 10. So take the derivative of both sides. Differentiate this. Sweet. First term, take the derivative and get 10x. Ooh, right here, this is going to be a product rule. The product of 3x and some function of x. Y is a function of x. So it's just right here that we need. F is going to be 3x and g is going to equal y. So it'll be f prime times g. Derivative of 3x is going to give you 3 times the function plus g prime times f. So add this times 3x. Let me make sure I did that correctly. This plus that was our product rule. Okay. We have a chain rule right there where we do subtract 3y with power 2, then multiply by y prime. And that y prime comes from the chain rule. All right, that was one side and is equal to the derivative with respect to x of a number 10. So it's all equal to 0. We are going to isolate y prime. So working on I guess let's get those terms next to each other and the other values on the other side. So minus 3y squared y prime. Okay, got those guys together. We don't need, well, we want this to be on the other side of the equation. So subtract 10x, subtract 3y. So we want to factor y prime out of that side. Solve for y prime by dividing both sides by that factor, 3x minus 3y. And another, wait, hang on a sec, I dropped that little power there. not there. Looks better. Okay, find y prime. Five to the y plus 3x squared is equal to e with the power of sine of y. We will take the derivative of both sides. This one, we have a number with a power y, and we're going to do that rule we've learned before as well as the chain rule. Okay. Is 5y ln of 5 times y prime. Make sure. Yeah. Derivative, then that derivative from the chain rule. This one is just a 6x. Add 6x. So if all you have is the variable x, you're just taking the derivative of that function, that part of the function in x with respect to x. So nothing to worry about. If there's this variable y, you have to remember that y is a function of x and use the chain rule. Okay, this side. E sine of y. Chain rule would give you to multiply by the derivative of the inside function, cosine of y. And then again, derivative of that inside function, which would be a y prime. So e to the sine of y times the cosine of y times y prime. And then isolate y prime. I want to see. I got that over there and then just divide everything through. So this part minus this part. Okay, factor out y prime. And that's all equal to negative 6x. Okay, so y prime would be negative 6x divided by all of that. And we're done. I have another example. And we'll see if we can get through that. And then we can kind of talk about something a little bit similar but different. We will find y prime. If cosine of x plus y minus 4 is equal to the tangent of x squared times y. We take the derivative of both sides. This will give you a negative sign, x plus y, multiplied by the derivative of the inside, which would be 1 plus y prime minus 0, that part there, and is equal to, so this part here, the derivative of tangent is going to be a secant squared x squared y. And then you're doing the chain rule, so the derivative of the inside, which is going to need a product rule. Okay, let's do this. So we need to do the product rule. I'm going to call f x squared. And we're going to call y g. So it's f prime g plus g prime f. F prime would be 2x. Add g prime f. And I think that's it. I just need to distribute everything and then isolate y prime. All right. So the negative sign of x plus y. Minus y prime sine of x plus y. Is equal to secant squared x squared y times 2xy plus secant squared x squared y times y prime x squared. Right, I need the terms with y prime on one side of the equation, everything else on the other side of the equation to isolate y prime. I would like to take this and add it to both sides. the y primes together. So we'll subtract that from both sides to get the rest on the other part of the equation. So we're just taking this and working with that part equal to secant squared x squared y prime x squared plus y prime. Okay, so from this side, we factor out y prime. So we've got x squared times secant squared of x squared y plus the sine of x plus y. And we've almost got y prime. We divide both sides by all of this to isolate y prime. So it would be this part. Let's make this. Negative sine of x plus y minus secant squared x squared y 2x y over anything else x squared. That would be your solution. Okay, so I will introduce the next idea, but we'll kind of end class in just a moment. So we'll come back next time and do an example for orthogonal curves. Two curves are orthogonal. If their tangent lines are perpendicular at points of intersection. Like at any point where the curves intersect, the tangent lines at that point are perpendicular. All right, we'll draw a picture and we'll come back next time and do a problem. So a sketch, drawing a circle. So kind of some form of a circle, and this is a multiple of the function x cubed, so kind of like this. And we'll talk about these functions being orthogonal right here and right here. So just for that part right there, we'd have a tangent line to the circle like this. And then a tangent line to y equals like x. In this case, let's say y equals x cubed. And along that way. And those tangent lines are perpendicular to each other.